Good day guys, I hope you're all doing so well. On today's episode, you're gonna deal with analytical geometry, question paper, question 2 specifically. I took this one from Mathematics Grade 10, 2018, November examination paper 1. Question number 2, analytical geometry. Now guys, the question statement reads as follows. In the diagram below, P 1:0, Q 6 and 3, and R 9 and -2 are the vertices of a triangle such that PQ is equal to QR and PQ is perpendicular to QR. T is a point on PQ such that T is the midpoint of PQ. S is the point of intersection of RQ and is the x-axis. V is a point on the x-axis such that angle QSV equal 121. QPS is equal to theta. Yes guys, now let us start with the first question. Question 2.1, it says determine 2.1 the length of PQ. Which means 2.1, it says that you must determine the length of PQ. Length of PQ. Now, PQ length. How do you determine the length of PQ? In any question near analytical geometry, you need to use the distance formula. What does the distance formula say? It says that if you want the length of PQ, and I say PQ is equal to, you open a bracket, x2 minus x1, close bracket, squared, plus y2 minus y1, close bracket, squared. It's either you put the squared here, at the end you must introduce the square root, or you already put the square root here for you to find the final answer straight. So I'd suggest you must just write the square root as it is and go through the final answer. Then just substitute coordinates of P. You can literally label your points in terms of x1, y1, x2, y2. So we can label PS x1, y1, x2, y2, and substitute on the equation. Hurry. Square root of what is your x2 is 6 here. You say 6 minus what is your x1? X1 is 1. 6 minus 1 squared plus what is your y2? 3. 3 minus what is your y1? 0. 3 minus 0 squared. Then you put the whole thing inside the calculator and it's going to give you a root of 34 units. This is the answer for the length of PQ. So hurry. PQ is equals to square root of 34 units. That's how you write the answer for that question. Now 2.1.2, determine the gradient of PQ. Gradient of PQ. Gradient of PQ. This is the M. PQ. Gradient of PQ is equals to y2 minus y1 over x2 minus x1. This is a formula used for gradient. Guys, I would suggest guys, you must have your formula sheet next to you for you to reference all the time. When I write these formulas, you must just always reference on your formula sheet to recall at all times. Yes, so please pause the video and answer the questions, then you just see the answers. After you've written yours, you must just watch to see what you've got it right or wrong. So please guys, just participate by pausing the video and doing the examples, please guys, that I'm doing right now. PQ the gradient of this line PQ. Since well now P and Q are already labeled, I can literally just substitute these values on the equation. Y2 is 3, y3 minus y1 is 0 divided by Q2 is 6, Q1 is 1. Then you put this on a calculator, it's going to be 3 divided by 5 and give the answer. 3 divided by 5. This is the gradient for PQ. 2.1.3. It says determine the coordinates of T, coordinates of this point T. Remember point T, they told you that T is the midpoint of PQ. Come on, for you to find the coordinates of T, you must use the midpoint formula. Can I use the midpoint formula? And you want to say about T on its coordinates are X and Y. Okay? And midpoint formula, it says that x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So now then T is the midpoint. Equal to. So now I got a midpoint there. This coordinates a midpoint of T, midpoint of PQ. Now midpoint of PQ already they are labeled x1, y1, x2, y2. Just substitute on this equation. X1 is 1 plus x2 is 6 divided by 2 and y1 is 0 plus y2 is 3 divided by 2. Then you just put that in the calculator. 6 plus 1 is 7. Then it's going to be 7 over 2 and 0 plus 3 is 3. Then it's going to be 3 over 2. These are coordinates of point T, the midpoint of PQ. Coordinates of T, the midpoint of PQ. Coordinates of T, the midpoint of PQ. Yes. 2.2.1. 2.2 says that you must calculate the 2.2.1, the area of triangle QTR. Choose this triangle, guys. Let me just draw the triangle so that you can see it. Now here's the triangle. Yes, this triangle in blue color. You must find the area of the triangle. I get the area of triangle. Area of triangle. Area of triangle. Area is equals to base times half times base times height. Okay, guys. So now, what is our base on the triangle QTR? Our base is this side QT, and our height is this side QR. So basically, you must find the length of QT and the length of QR for you to be able to determine the area of triangle QTR. You must find the length of QT and the length of QR. Let's find the length of QT and the length of QR. Have you guys? The length of QT is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. Thank you. Alright, QT. I give it about a T. I give it about, you have labeled Q as x2 and y2, and you can label T as x1 and y1. Simple, like yes. Already Q has got x2 and y2. I can label T as x1 and y1. So x2 is 6. 6 minus x1 is 7 over 2 squared plus y2 is 3. 3 minus y1 is 3 over 2 squared. Then the length of QT is, you put that on the calculator. The length answer is going to be the square root of 34 over 2. Okay. Yes. So now I'm going to write it here. QT half multiplied by the square root of 34 divided by 2 multiplied by, we're just going to find the length of QR, the length of QR. What is the length of QR? Now QR, you can label QR. So Q already is x2 and y2. R we can label the x1 and y1. Okay. So x2 is 6. 6 minus x1 is 9. Okay. Squared plus y2 is 3 minus y1 is minus negative 2. So it's going to be negative 2 inside the bracket. We close the bracket squared. Thank you guys. Very important to introduce brackets whenever you've got a situation like this one. So I'm going to give out the square root of 34. The square root of 34. So in the length of QR, it is the square root of 34. Thank you. So the area, I'm done with calculations. Thank you. I'm just finishing everything off. Now the area here is going to be 8,5 units squared. This is the area for triangle QTR. I hope we are all clear on that one. Yes, guys. 2.2.1. We go to 2.2.2. It says that determine the size theta. Determine the size theta. Now, guys, where is theta? And theta is in this triangle. This one. Okay. This triangle here. So in this triangle we've got theta. Here's my theta. And you are about this triangle here. This one. This triangle. This one. This one. Focus on this triangle. This one. Inside that triangle we've got 90-degree angle. At Q you've got 90. Then you've got theta. Now we've got 121 outside the bracket. Outside the triangle. Okay, this 121. This angle 121 outside the bracket. Label. So when you go back to the rules of triangle, it says that the exterior angle of triangle is equal to the sum of the opposite interior angles of the triangle. This angle like 121 is equal to the sum of theta plus 90. Bible. I hope you're clear. Which means this angle 121. And give us about angle QSSV is equal to theta plus angle Q. Why are we saying QSV is equal to theta plus angle Q? Because of what? Exterior angle of triangle. This is the reason we use exterior angle of triangle is equal to the sum of opposite it. Angle triangle. Angle 121 triangle. Triangle theta 90 degrees. I give angle QSV 121. And this angle 121 equal to theta. And this angle Q is 90 degrees plus 90. And you guys, therefore, theta is equal to, I'm going to transpose this 90 to the left. And it's going to be 121 minus 90. 30 31 degrees. My theta is 31 degrees. 2.3. It says that determine or calculate the coordinates of S. Coordinates of S is this point here. This point here. That point is, that's where we're going to find coordinates of S. Now, that point, coordinates of S in that case are X and 0. Why? Because that point S sits on this linear x-axis. And you how any point that lies on the linear x-axis, it means its y coordinate equal to 0. Okay, guys, which means its y coordinate equal to 0. That is the x-intercept. And you this point here is our x-intercept. Coordinate thing x-intercept. And point S is our x-intercept. Therefore, if x is our x-intercept, therefore you let y be 0. Once y is 0, then you're gonna find x. Okay. Now, how do we find coordinate S in this case, guys? Since our aim is to find x coordinate of point S. That's our aim. So how do we find the equation? QR. Okay. So I just write the equation of QR. So how do we find the equation of QR? Now, remember that we are given the gradient there PQ. Okay. So for us to find the equation in QR, remember the straight line. Okay? Equation of straight line in a gradient. So for us to find the equation of QR, we ought to know the gradient of QR. How do you find the gradient of QR? Remember, we've got 90 degree angle. Between QP and QR, there is 90 degree angle. And whatever, if 90 degrees, for us to find the gradient of the other side, if you multiply the two gradients, they must give you -1. So that means the gradient there, PQ, multiplied by gradient there, QR, should give us -1. So for us to find QR, this is one of the ways to find the gradient of QR. What the gradient of PQ is 3/5. 3/5 multiplied by gradient there, QR, therefore equal -1. Therefore, we divide both sides by 3/5. 3/5. For us to find the gradient of QR, we divide both sides by 3/5. Therefore, we're going to say -1 divided by 3/5. The answer is going to be -5/3. This is the gradient for QR. -5/3. And yes, -5/3. Therefore, y equal to mx plus c. So now, yeah, -5/3 x plus c. And about the equation of QR. That's our aim. Equation of QR. Now, about c again, c. About the equation again, c, our constant. How do we find c? We're gonna use between these two coordinates, the q and r, to find c. I can use the r. Where cx I put in 9. Where cy I put in -2 to find c. Hurry. Y -2 equal to -5/3x. Where cx I put in 9. Yes, 9 plus c. So I'm going to transpose this thing, all of it, to the left, because it's our constant. -2 is our constant. Yes. Now I'm going to change the sign from negative to positive. And you talk about -2 plus C is 13. C equal to 13. Are we clear, guys? Are we clear? We are not done. We just found the equation here. Yeah. QR. So it's y equal to -5/3x plus 13. Now to find s, where I see y I put in 0 to find x. So y I want is 0. 0 is equal to -5/3 x plus 13. I'm going to transpose this 13 to the left. So I be -13 equal to -5/3 x. I'm going to divide both sides by -5/3. -5/3. Guys. Then it's going to divide this one, and therefore x ya rona is going to be equal to negative 13 divided by negative 5 over 3. The answer is 39 over 5. That is our answer for that question. Therefore, coordinates are S are 39 over 5 and 0. These are coordinates of S. You are done, guys. For 2018, you are done. Let's go to 2017. Yes, guys, we are back with the question paper 2017, question 3, analytical geometry. Ne? Question number 3 and 3.1. It says that, okay, before that I can read the statement here. It says that in the diagram below, P7 and 4, Q6 and 6, R0 and 3, and S, T and K are the vertices of a quadrilateral PQRS. 3.1. Calculate the length of PQ. The length of PQ. The length of PQ. Very important. Length of PQ, you already know one here. Any question that talks about the length, you must just say square root x2 minus x1 squared plus y2 minus y1 squared. Thank you, guys. That was simple. Then you just label your coordinates there. You can just say x1 y1, x2 y2. And hurry, x2 is 7, x1 is 6 squared plus y2 is 4, y1 is 6. Then close the bracket, you introduce the square root sign and your calculator. Root of 5. The answer there is the square root of 5 units. This is the length for PQ. Very important. So you must just write it down here. PQ is equals to the square root of 5 units. Very important, guys, to write these answers because they might be needed somewhere down the questions. Yeah. Let's go to the next question, 3.2. 3.2, it says if T, which with coordinates 7 over 2 and 7 over 2 is the midpoint of QS. Very important. Determine the coordinates of S. Since if they're saying if T is the midpoint of QS, so this QS, here's my QS, and here's my QS. If Barry T is the midpoint here, Barry T is midpoint 7 over 2 and 7 over 2. If Barry these coordinates, they are our midpoint, therefore determine the coordinates of point S. And you need to look at this the midpoint again. Now we are given the coordinates of our midpoint, which is 7 over 2, 7 over 2. If you are given the coordinates of your midpoint, these coordinates are on. These are our x and our y coordinate. Whatever we've got our equation formula x1 plus x2 from midpoint that by 2 and y1 plus y2 over 2. And this one is equals to you are given the coordinates of the midpoint. It's going to be a different story. If you are given the coordinates of a midpoint, you must substitute them here before the equal sign or in front of the equal sign. For the x 7 over 2, x, these are x coordinate. Therefore, you're going to put this x coordinate on the side of x's. So it's about 7 over 2 and is equals to, we can label the coordinate. And here we have labeled x1, y1. It's going to be x2, y2. And right, x1 is 6 plus x2 is t and plus t over 2 and is 2. the y side, and you take the y coordinate, which is 7 over 2 again. You're gonna say 7 over 2 is equals to your y1. Apologies guys. What is it in here? Oh, y1 is 6, and I give about like qs. Y1 is 6, yes, plus y2 is k, yes, yeah, correct, over 2. Therefore now at this stage you must solve for t and solve for k. Okay, let us solve for t on this side. Hurry. In this case, I give whatever you cross multiply. You cross multiply. Yes. In this case, when you cross multiply, it's gonna be 7 times 2 is 14, equal to 2 times 6 plus t. And here what 2 times 6 plus t. And here, so yeah. Then to continue with the answer, you want to find t. You multiply this 2 by 6 and 2 by t. And here, yes, 2 by 6, 2 by t. So 2 by 6 is 12, plus 2 times t is 2t. And 2 by t is 2t, yes. Equal to 14. Therefore, one transpose this 12 to the left. And I give what I like times. 14 minus 12 is 2, and here equal to 2t. Therefore, divide both sides by 2 by 2. Therefore, t arona is equal to 1. I give 2 divided by 2 is 1. And we are done with this side, and you come into this side there, k. The very same method, I'm going to cross multiply. 7 times 2 is 14. 14 is equal to 2 times 6 plus k. And 2 times 6 plus k. And what's even 2 times 2, 6 is 12. 2 times k plus 2k and equal to 14. I'm going to transpose this 12 to the left. About 14 minus 12 is 2 and equal to 2k. Then you got a k, I divide both sides by 2 by 2. Therefore, k equal to 1. So coordinates are s are 1 and 1. This is a coordinate of s and 1 and 1. 1 and 1. We are clear, guys. I hope we are all clear on that one. 3.3 guys, it says that if the coordinates of s are 1 and 1, show that PR equal to QS. You must show that PR equal to QS. PR, this line equal to QS, this line again. So this line here, this one, this line equal to this line in terms of what? Length. So you need to find the length here, PR, and the length of QS. You must just prove them could they're equal. Yes, how about the length of PR? That's it. PR equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And guys, the square root here. Then for PR, x2 and y2, we can label this one x1 and y1 again. So x2 is 7 again. 7 minus x1 is 0 squared plus y2 is 4 minus y1 is 3. Put this on calculator. 5 square root of 2 means this is the length here, PR. Now for us to prove that they're equal, the length of QS should also be equal to 5 square root of 2. So length of QS is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. Here guys, then the square root here, what is the x2? I get QS and get, yes, QS. So the length of QS, x2, how much is it? Is 1 here. 1 minus x1 is 6 squared plus y2 1 minus 6 and 5 square root of 2. The length here is 5 square root of 2 units. This is the length here, QS. Therefore, you just conclude, therefore, PR is equals to QS. You have proven it literally. The length, they are telling us the length 30. That's how you prove it, guys. I hope you are clear on that one. Let's go to the next question. Next question. Also the length here, which means if by the length here QS equal to the length here PR, it means go to the diagonals are equal. The diagonals are equal of this quadrilateral. 3.4, it says that show that QR is perpendicular to RS. QR, you must show QR is perpendicular to RS. QR perpendicular to RS. QR and R. Which means you must prove this angle here equal to 90 degrees. Okay. That's what you must prove there. Basically, it means at the end, if you must prove that, it means you must prove this is 90 degree angle here. How do you prove that angle is equal to 90 degree? You must find the gradient each side, and when you multiply this gradient after, it must give you -1. Okay, how about the gradient QR? Gradient QR is equal to y2 minus y1 over x2 minus x1. I get this. You get the QR in a QR. So I can label them. I get x1, y1. I can just label this one x2, y2. So y2 you wanna keep like 3. Y1 is 6. X2 is 0. Then y1 is 6. Then my answer here is going to be 3 minus 6 is -3. Then -3 divided by -6. The answer is gonna give me 1/2 half. I'm done with that one. I'm gonna go to the current there. RS equal to y2 minus y1 over x2 minus x1. RS, I can label them properly. X2, y2, I can literally label this one x1 and y1. It's not a problem. Yes, so it's 1 here. Now y2 get 3 for R. Y1 is 1 again, now S divided by 2, and x2 is 0, then x1 is 1. Then the answer is going to be 2 divided by -1 is negative. The answer is -2. So after I found the two gradient, I need to multiply them, and the answer should be -1. I need to prove that -1 is indeed gotten after you have multiplied the two gradient. So the gradient there, QR multiplied by the gradient there, RS. You need to prove what is equals -1 is equals to, I multiply 1/2 multiplied by -2. And if you the multiplier, they must give me -1. 1/2 times -2 is -1. If they give me -1, you therefore conclude, therefore QR is perpendicular to RS, because they have shown when you multiply the gradients, they give you -1. That's the aim, basically, guys. I hope we are all clear. 3.5. So yeah, Now 3.5, guys, it says that, so therefore it's 90 degree. Yes, then therefore 3.5, it says hence what type of special quadrilateral is PQRS. So guys, they are asking what type of quadrilateral is PQRS. Remember, different types of quadrilateral. Square, trapezium, kite, rectangle, parallelogram, and many others. Yeah, so now you need to know the properties of those triangles, or those quadrilaterals. You need to know the properties of those quadrilaterals. It's very important to know the properties of those quadrilaterals. And if you can check, go to what type of triangle into a quadrilateral, this one we know go to is a rectangle. Rectangle. Why are we saying it's a rectangle? Because the diagonals are equal. The diagonals are equal, and one of the interior angles is equal to 90 degrees. Means the diagonals, diagonals are equal, and one of the interior angle is 90 degrees. And you just prove which is 90 degree angle and the diagonals are equal. That's what we must prove there. I hope the answer is clear. The last question. You need to know the properties of quadrilaterals. It's very important to know the properties of quadrilaterals, guys, before you can attempt analytical geometry. You need to know the properties of quadrilaterals. You need to know them by heart. Please. 3.6, it says that calculate the size of angle RSQ. Angle RSQ. Which angle is RSQ? RSQ means this angle here, this angle. This one. This angle. Very important, guys. That angle is very, 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 very important. Now, how do you find that angle? Since well now, this is a right angle triangle, you can use trigonometric ratios to find that angle. We can use trigonometric ratio to find that angle. How do you find that angle? We can use, if we have got this angle and 90 degree, it means you can use this is our adjacent side here, this one. Because we've got two angles. If we need to find this one, it means this side is our adjacent. So we can take adjacent over hypotenuse. And what's about cos theta is equals to adjacent over hypotenuse. In this case, in this context, you about the angle RSQ and you about cos RSQ equal, what is our adjacent is RS. What is our hypotenuse is QS. So we need to find the length here, RS and QS. Very important. RS and QS. That's our aim for now. Let us find the length of RS. RS is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. Thank you, guys. Then x2, and that's about RS. RS again, and get this slide. X2, you guys, get 0, and get 0. You just level them, and get x1, get 1, and get plus y2, get 3, and get minus y1, get 1. Then the answer, the root of 5. So I must write it down here. So this one is going to be equal to the square root of 5. Then how the length here QS? Length here QS length ya QS and QS, this one again, length in a so I can label them properly, guys. So I can label this one x2 and y2. Sorry, x2 is 1, s1 minus x1 is 6 squared plus y2 is 1 minus 6 y1 squared 5 and square root. This is the answer for this is the length for QS and yes, guys. So I'm gonna substitute here 5 and the square root of 2. I'm not done. I just about the angle. You want to find the angle here, guys. Now how about the angular RSQ? You wanna say cos RSQ is equals to. I get about the answer. I get about bracket of square root of 5 on at the bottom is 5 square root of 2. So when I divide this two numerator and denominator, I get square root of 10 over 10. I divided them. I said the square root of 5 divided by 5 square root of 2. It gave me square root of 10 divided by 10. Therefore, I got RSQ. I'm gonna introduce the inverse cos -1 square root of 10 over 10. The inverse again. I get that the inverse again. Okay, you just found the answer square root of 10 over 10. You can just say shift. You say shift and you go to cos. It says cos to power -1 and just say answer. Answer how I give it the very same answer as square root 10 over 10. Then just say equal to, it gives us 71,57. 71,57 degrees. This is your answer for this question. I hope we are all clear on that one. Thank you very much, guys. Up until the next chapter for mathematics. Thank you very much. Enjoy your lesson.